Welcome to section 0.4 day 1, nth roots and real exponents. Today's objectives are to simplify expressions in radical form and to simplify expressions in exponential form. The nth root of a number. Let a and b be real numbers, and let n be any positive integer greater than 1. If a equals b to the nth, then b is an nth root of a. If a has an nth root, the principal nth root is the root having the same sign as a. So we're going to be working with principal roots today. So we'll have the same sign as the radicand. And the principal nth root of a is denoted by the radical expression, the nth root of a, where you have the index is n and the radical symbol, and then you have a, which is the radicand. So if we're looking at the fourth root of 81, the fourth root of 81 is 3. Notice we have the same sign. Now what's different with this is today we are just working with expressions, so we're just going to use the principal root. When we have equations later on, like when you did the quadratic formula the other day, we had to add the plus minus. But today we are working with expressions, not equations, so we're just looking for the principal root. The same sign as what's in the radical. Now we have the opposite of the fourth root of 81, so this is negative 3. Then we have the plus minus signs. That means we bring the plus minus sign with, and the nth root of 81 is 3. Then we have the cubed root of negative 27. We could take the cubed root of a negative number because a negative times a negative times a negative is negative. So we're going to bring a negative out. And the third root of 27 is 3, because 3 times 3 times 3 is 27. So our answer is negative 3. So all right, whether a radical expression has positive and or negative roots depends on the value of the radicand and whether the index is even or odd. This is showing what happens when we have equations. Today we're going to be working with expressions. But it does show that if a is greater than 0, we have a positive number under the radical. And n, the index, is even, like 2, 4, 6, 8. We're going to have a positive and a negative real root. So that's when we solve an equation. Today we're doing just a principal, which will have the same sign. We're just going to have positive roots when we have even indexes. When a is less than 0, we cannot take them in the real number system. We'd have 0 real roots. We need imaginary numbers to solve those. And when a is 0, the nth root of 0 is 0. When the index is odd, we get, if a is positive, we get a positive real root. If a is less than 0, which is negative, we get a negative real root. And again, the nth root of 0 is 0. For our examples below, we have the opposite of the square root of 49. Remember, if we don't have a number written there, it defaults to the second or the square root. And this would become, the root itself is 7, but we have the opposite of 7. We have the cubed root of 64 over 27. The cubed root of 64 is 4. The cubed root of 27 is 3. We have 4/3. Then we have the fourth root of negative 121. We have a number less than 0. That means there are no real roots. We can't take the even root of a negative number. So no real roots. All right, so basic properties of radicals. Product property is that if you take the same index of two different terms, so you have the nth root of a and then nth root of b, we can combine the radicals and multiply them together and make it into one radical, the nth root of a times b. And it works both ways. That means the nth root of ab can be split up into the nth root of a times the nth root of b. The same thing works with division. All right, so when you're dividing, we can break radicals up across division or combine as long as we have the same index. So here we're going to simplify radicals. The first one we have is the fourth root of n to the 12th. Well, if you remember how rational exponents work, this is the same as n to the 12 fourths, which is the same as n cubed. Well, what's one of those things that's interesting with these, when you have inside, you have an even index, that's at 4 is your index. And if you have an even power in the radical, and then when you simplify it, you pull out a odd power, when you do these, you need to add something to your answer. You need to add absolute value bars. So this is actually going to be the absolute value of n cubed. You could put the cubed on the outside of the absolute value bars. That part doesn't matter, but we need absolute value bars. The reason for this is if we have n to the 12th inside the radical, and you put a number in there like a -2, and you took it to the 12th power, you would get a positive number. And then when you took the 4th root of that positive number, you would get a positive number. So we have to make sure we get a positive number back. With n cubed, if we put a negative number in for n right now, we would get a negative number back without the absolute value bars. So we need to use the absolute value bars so it makes sure we get the same type of answers we would have gotten originally. So whenever you have an even index with an even power and you pull out an odd power, you have to use absolute value bars. Because we have restricted it, we can only have positive answers from our original, so our resulting answer must only give us positive answers. That is one of the trickier things with this. All right, so we are going to now simplify part B. We have the 4th root of 81 and then a plus 1 to the 12th power in parentheses. I'm going to break this up. So we have the 4th root of 81. We have the 4th root of a plus 1 in parentheses to the 12th power. And you don't need to show all these steps. I'm just trying to show you everything. The 4th root of 81 is 3. Then we have a plus 1 to the 12th power. We have 12/4, which is also 3. So we have a plus 1 to the 3rd power. And again, we started with an even root and an even index, and we pulled out an odd power for a plus 1. So we need to use absolute value bars. And again, the absolute value bars can be just around the parentheses and then raised to the 3rd, or the whole thing to the absolute value. So this is my solution. For part C, we have the square root of 63y cubed. I break mine down. You guys don't need to show all this, of course, but I'm going to break it down to perfect squares. We have the square root of 9y squared, because 9 is the largest perfect square out of 63. And we have 7y left. And then for this, we simplify, we get 3y square root 7y. So you'll notice this one I did not put absolute value bars on. The reason is, in the first problem, when we tried to put a negative number in for y, we wouldn't be able to take a square root because we have a negative number under the radical. Unless we're working with imaginary numbers, we would not be able to take the square root of a negative number. When we do our simplifying, we still can't put a negative number in for y because we'd be trying to take the square root of a negative number, which we can't do with real numbers. So today when we're doing this, we're not going to be dealing with imaginary numbers. So if you have an even power on a negative number, we do not have a real solution, and we won't do it. So this one does not need absolute values. All right, and then part D, we have the 5th root of negative p to the 10th q to the 7th. And I will break this down so you can sort of see what's going on. We have the 5th root of negative 1. We have the 5th root of p10. We have the 5th root of q7. We can break these down across multiplication. That is a q, by the way. And then from here, the 5th root of negative 1 is negative 1. You don't need to write the 1 part because we're going to have some other stuff. The 5th root of p to the 10th is p squared. The 5th root of q to the 7th is q on the outside, with the 5th root of q squared left over. Like I said, you don't need to have the negative 1. We usually don't write it in our final answers. This is q, and this is q, the 5th root of q squared. So this is my final answer. So the biggest thing with this, again, is what I wrote on the top here. If you have an even index with an even power and you pull out an odd power, do not forget the absolute value bars. around whatever you pulled out. That is all for section 0.4 day 1. Today we looked at nth roots and real exponents, and we simplified radicals. Thank you for watching, and have a nice day.